Okay, let's dive right into this. Welcome to the Explainer. Today, we're taking a really fascinating look at the mechanics of Java web development, specifically pulling from the excellent insights found in Mr. Ravikant Sir's sessions 48 and 49. We're tackling a challenge that honestly every Java web developer faces: demystifying Thymeleaf and mastering dynamic URL mapping. If you've ever stared at a static HTML page and wondered how to seamlessly inject unique, dynamic Java data right into your routing, well, you're exactly where you need to be. So, it all starts with an absolutely critical question. How exactly do we map dynamic URLs in a Java application without breaking everything? Think about it. When you have a list of user profiles or products in a database, each one needs its own unique link. An edit button, a delete button, you name it. You obviously can't just type out 100 different links manually. No way. We need our application to build these links on the fly, accurately every single time a page loads. So today, we're going to solve this exact coding challenge by building that URL piece by piece. Here's our quick roadmap for today's lesson in URL anatomy. We'll start with the dynamic URL change, introduce our core mechanic, the THREF attribute, and then build our static path. Finally, we'll append dynamic ID parameters to reveal the complete final URL anatomy. Starting with section 1, the dynamic URL challenge, and moving beyond those rigid, hard-coded links. You know, in the source sessions for today's explainer, Mr. Ravikant Sir is teaching this incredible logic. But occasionally he has to pause because his voice is breaking or the network starts stuttering. It's incredibly relatable, right? But it actually highlights a beautiful truth about programming. The code remains perfectly logical and structured, even when the network doesn't. But while our Java backend logic is super resilient, relying on standard static HTML anchor tags to handle dynamic data is anything but. We absolutely need a smarter way to connect our backend variables to our front-end web pages. That brings us straight to section 2, introducing the THREF attribute, which is the core mechanic for this entire process. Now, think about the contrast here. With standard HTML, you have your classic href tag. It's great for static websites, but for a dynamic Java application, it literally falls completely flat. It doesn't know how to talk to your Java backend at all. But then, Thymeleaf introduces the THOF attribute. By simply adding that th: prefix, we're basically telling our application, hey, don't just read this as plain text. Process this link using the server-side data. It's a total game changer and a true evolution of the basic anchor tag. But wait, we can't just throw normal text inside that new attribute. Notice the specific punctuation here, the @ symbol immediately followed by open and closed curly braces. In Thymeleaf, this @ symbol and curly brace syntax acts as the essential container for our URL. It literally screams to the Thymeleaf engine, everything inside these braces is a link expression that needs to be evaluated right now. It is the absolute foundation of everything we're about to build. Let's move along to section 3, building the static path and routing to our controller. Because, every dynamic link still needs a fixed destination to start with. Think of this exactly like assembling building blocks. We start with our empty shell, our base attribute, THHF, with our @ symbol and curly braces. Inside those braces, step 2, we add our static class level path. In our source example, this is /stot. This tells the application which controller to go to. Then, step 3, we add the action path, in our case, /delete. This tells the controller exactly what we want to do once we actually get there. So before we even touch anything dynamic, we firmly established our baseline coordinates, /d/delete. This static path serves as the exact routing instructions telling the Java application precisely where to direct the user. It is highly structured. But right now, it would just trigger a generic delete action. It doesn't actually know what to delete. We're essentially missing the target. And that is exactly where section 4 comes in, appending dynamic ID parameters by injecting our variable. To pass a dynamic record, say a specific user ID, into our path, we need a brand new piece of syntax. Notice how this differs from our linked container. This is the $ and curly braces. In the Thymeleaf engine, the $ means variable extraction. It evaluates whatever is inside those braces and literally injects its actual value from the Java backend directly into the HTML page. So the crucial point here is captured beautifully in this quote from the source session. Make this one as a key. When we map our ID parameter, we are treating that dynamic variable as the absolute unique identifier. It is literally the key that unlocks the specific record in our database. We're telling the controller, hey, execute the delete action, and here is the exact key for the item you need to delete. Let's move to and see how this builds completely in Section 5, the final URL anatomy, putting it all together. Let's break down our complete reconstructed URL block step by step. At the outer layer, we have our @ symbol and curly braces, which wraps the whole shebang and tells Thymeleaf we're dealing with a link. Now, moving quickly through the static blocks we've already covered, we have /st, which routes us to the correct controller class, and then we hit /delete, which routes us to the specific method or action. But here is where we need to slow down and look really closely. We append our dynamic key using parentheses. Inside the parentheses, we declare our parameter, ID, set it equal to our variable container, the $sign and curly braces, and place the actual item identifier inside. It's like a giant puzzle, and every single block works together in perfect harmony. The syntax definitely looks complex at first glance, but when you break it apart like this, it's incredibly logical, right? To quickly summarize our URL breakdown, we've completely ditched those rigid static anchors for the really powerful href attribute. We've used the @ symbol to contain our link, injected our static routing, and securely locked in our dynamic keys. We went from an empty tag all the way to a fully functioning dynamic path mapping. And this brilliantly illustrates just how elegant server-side rendering can be when you truly understand the syntax, which leaves me with a final question for you. How will you utilize this dynamic mapping to streamline your own real-time Java projects? Now that you actually know how to build a dynamic URL piece by piece, you possess the keys to unlock significantly more complex, data-driven web pages. Thank you so much for joining me for this explainer. Keep your code logical and happy programming.